Let's revisit our discussion of principal and interest on loans again. Recall we found that if we borrow P0 for T years with an annual interest rate R and interest compounded continuously, then the amount owed is given by P of T equals P0 times e to the RT. In our next example, we want to know when will we owe $18,000 if we borrow $15,000 with a 6% interest rate compounded continuously. The word when is asking, what is t? Building our model, we get that P of t equals 15,000 times e to the 0.06t. But on the other hand, we are trying to figure out when P of t equals $18,000. Dividing both sides by 15,000, we get that e to the 0.06t equals 18,000 over 15,000. And we can reduce the left-hand side down to 6/5 or 1.2. So the equation we want to solve is 1.2 equals e to the 0.06t. How do we get at t when it's in the exponent? The answer is logarithms. We define the function f of x equals ln of x as the inverse of the function y equals e to the x, and is called the natural logarithm. What we mean by inverse is that the natural log of e to the k equals k for any value of k. In other words, the natural log undoes what e does. Additionally, e to the ln of k equals k as well. That means that e undoes the logarithm. Back to our equation, 1.2 equals e to the 0.06t. To get at t, we need to take the natural log of the right-hand side. But to take the natural log of the right-hand side, we must also take the natural log of the left-hand side. Using what we now know about the logarithm, the right-hand side is simply 0.06t, where it is playing the role of k. To solve for t, we now simply need to divide both sides by 0.06. So t equals the natural log of 1.2 divided by 0.06, which simplifies to 3.04. So it takes just over 3 years for our loan to go up to $18,000. It is worth noting that we can compute the natural log, ln of x, using our calculators. And also, it is best to wait to compute until the end to avoid rounding errors.